Any questions? Yeah.
Going to move on to the next speaker and save questions for the discussion period, if just to keep on schedule a little bit here.
Yes, so our next speaker is Irfan Azeem, and we're going to talk about the one-NOAA strategy.
Right, thank you. So again, thank you for the opportunity to talk about one-NOAA space weather strategy. I'm Irfan Azeem. I'm the Division Chief for Science and Engineering within Office of Space Weather Observation at NOAA NESDIS. Some of you may not have heard the one-NOAA strategy is a fairly new effort within NOAA, and it involves separate line offices. So some of you may not have heard of this strategy or this effort, but I thought this workshop attendees might be interested in getting an update on the one-NOAA strategy and what it really is, as data assimilation is one of the key or one of the priority areas of one-NOAA strategy. So this is just a quick outline. I'll just kind of give you an introduction and motivation. How do we get to the stage where we started the one-NOAA strategy? And then I'll really give you a very high level overview what is in the one-NOAA space weather strategy and talk about who is involved in the one-NOAA space weather strategy core team. I'm one of the members of the core team for the one-NOAA strategy. And then also identify what are the line offices that are actually working on the core strategies. And you will see it's not just SWPC, it's not just our office. There are actually other offices within NOAA involved in developing this strategy. And then I'll give you the status, where things stand in terms of the strategy and its implementation, and what's our path forward. So if you have worked in the terrestrial weather, you know NOAA is a trusted source of environmental information, both from space-based observation as well as surface-based observation, including space weather. So NOAA has provided space-based environmental information since the 1960s and will continue to do so well into the future, because our next generation's satellite architecture is designed to go well beyond into the 2050s, and providing a national backbone for for environmental observations. So NOAA's mission will continue to evolve as our user needs change over time. With that in mind, the NOAA, our NESDIS office is really looking at our next generation space-based architecture into 3 different portfolios: LEO, GEO, and space weather observations. So space weather observations, we're looking at satellite architecture that can provide operational space weather observations from different vantage point, from L1, GEO, LEO, as well as perhaps off Sun Earth line and even sub L1 vantage points. For space weather, NOAA provides space weather observations to enable decision makers as well as space weather data users to be able to plan for and mitigate for harmful space weather observations. And NOAA provides observational space weather data through satellite data through NESDIS space weather observations, and to some extent through the GOES-R program. But going forward, the space weather observational data from satellite will come from the Office of Space Weather Observations. And also, I think Subhay mentioned that there's National Weather Service is also pursuing efforts to get surface-based space weather data from different partner sources. Storm forecasting for space weather is provided by Space Weather Prediction Center, and then data management and stewardship is provided by the NESDIS NCI. Space weather is a national priority. The effects of the space weather, as previous speakers have already alluded to, the space weather poses a significant increasing societal and economic, as well as national security and health risk to the United States. In a recent study, There was an estimate for the economic impact of the severe space weather event to be between $2 to $3 trillion. So it's a big economic impact that we need to mitigate. Sue mentioned the impacts of space weather to electric power grid through ground-induced geomagnetically induced current, aviation operations through increased radiation, position and navigation and timing services due to variability in the ionosphere, and satellite and space-based communication, again, due to the changes in the ionosphere. The effects of space weather is one of the 6 critical areas that has been identified in the NOAA 20s in the weather, the water and climate strategies that was released a few years ago. And again, these critical areas or these challenge areas really were identified and they provide a focal point for developing a weather and climate radiation. Enhanced space weather decision support is a national imperative as identified in the ProSwift Act that was signed in 2022. So NOAA's responsibility for providing operational space weather observation for the civilian applications include providing observation from both space-based observation as well as surface-based observation, and building a capacity to advance the space weather policy as identified in the space weather National Space Weather Strategy and Action Plan, as well as the ProSwift Act. So both of those documents really identified the NOAA's roles and responsibility, and NOAA is taking efforts to address those responsibilities and accelerating the growth in NOAA and in space weather services through providing timely, accurate, and relevant model and observations. And then finally, one of the NOAA's space weather responsibility also includes integrating and approaches and collaboration between research to operations. So really taking the work that is being done in the research arena and identifying which of those can be transitioned into operations. The ProSwift Act integrates national space weather activities and codifies and it strengthens efforts towards the whole of community approach for space weather. NOAA's responsibilities, as described in the ProSwift Act, include providing operational space weather monitoring observations and also making sure that those data are archived for access for civilian applications, maintaining ground-based as well as space-based space weather observations, and providing research to operation support, and developing requirements for space weather forecasting technologies and science. The ProSwift implementation, there's the Space Weather Advisory Group that advises the SWARM, the Space Weather Operation Research and Mitigation Subcommittee, to ways to help facilitate and implement the ProSwift actions. So they have provided several recommendations, and I'm not going to go through all of them, but the one that I want to mention is the expand NOAA R2O2R functionality to enable transition to full operations. And this is one of the areas where we recognize that the NOAA is not perhaps well resourced to really take advantage of the research to operations effort. Okay, this is an older version of my talk, but that's okay. So one of the things that we have recognized within NOAA is, let's say, how do we, well, as I say, we're not fully resourced to execute all of our responsibilities in the ProSwift Act. So we have taking an enterprise-wide look throughout NOAA to advance the NOAA space weather across as an enterprise. So as part of that, we have started this effort called one-NOAA strategy to align priorities and build connective tissues between different line offices within NOAA that are involved and could be involved in space weather observations, providing space weather research, or improving space weather forecasting and modeling. And that includes, for now, NESDIS, the National Weather Service, and OAR, which currently is lacking a space weather program. So OAR provides applied research support for terrestrial weather or ocean research, but for the time being, or for as things stand now, they really don't have a space weather research program, and that's what we want to address. So what is one-NOAA space weather strategy? It's a NOAA-wide plan to prioritize the space weather as a collective effort. So right now, there is a perception that a lot of the space weather research within NOAA is sort of disjointed, and we want to look at an end-to-end, develop an end-to-end approach where we have a cohesive effort that looks at space weather through the entire value chain, from observations to simulation into models to creating data products, and then providing forecast and warnings and value-added products to end users. The plan seeks to foster collaboration and integration of space weather research, whether it's for improving observations or modelings of creating new data products across the entirety of NOAA. So the strategy outlines plans to coordinate and improve space weather products and services, improve NOAA's applied space weather research capability, and then also use the one-NOAA strategy to really build up the workforce within NOAA that can support our space weather effort. So one-NOAA space weather core team includes 3 line offices, the National Weather Service, National Environmental Satellite Data and Information Services, as well as Office of Oceanic and Atmospheric Research. And within these 3 line offices, you will see there's multiple offices that are involved in providing input into developing this one-NOAA space weather strategy. So SWIPC, Office of Observations, EMC, NCEP. From the Weather Services, they are part of the core team. From NESDIS, it's Space Weather Observations, NCI, STAR, and from OAR, we have the Weather Program Office, CFO, because one of the recognition is that we cannot achieve this if we don't have the resources, or we don't have the funding to stand up a space weather research, applied space weather research program. So the current focus is on 3 priority areas. Data, I'm not going to go through all of them, but the most important one for this group here is the data simulation. So if you've recognized, we're collecting a lot of space weather data, and Sue Wei alluded to that in her presentation. We're getting commercial data from for ionosphere. We are collecting data from Cosmic 2 on the ionosphere. We're collecting data from GOES-R. A lot of data is not being most efficiently being utilized in our models through data simulation. So we want to make sure that we recognize that, and then focus on developing sustained effort to provide applied research resources for data simulation across NOAA. So the sub-team members and the other 2, if I can go, the other 2 focus areas for the current one-NOAA space weather strategy is the space weather operations and the research to operation, operation to research. The sub-team membership, again, if you look at this table, you will see that there's multiple offices that are providing their feedback and input into developing priorities and actions for each of these focus areas. So for the data simulation, we have membership from STAR, EMC, SWIPC, SWO, OPS, NCI, as well as OAR. And then similarly, we have membership from different offices for the other two focus areas. So what's the current status and of the one-NOAA strategy? The high-level strategy was recently signed by the three AAs of participating line offices. So NESDIS, NWS, and OAR. The sub-teams, the three sub-teams, they are currently developing list of activities, both what needs to be done next year within a 1 year time frame, 3 years and 5 year time frames, and then identifying prioritizing those list of activities, identifying gaps in areas where existing efforts could be leveraged, because one of the challenges that we currently don't have a budget to, there's a chicken and egg problem. We want to leverage some ongoing efforts to show progress so that we can reach out and request some additional funding to really start it on the applied research for space weather in earnest. The core teams co-lead and prioritize the list from the sub-teams and then provide their feedback for the implementation process. And in the future, both the ESIB and the weather team will begin looking at one-NOAA space weather strategy for milestones that can demonstrate progress in this area. So just want to conclude by saying that NOAA space weather mission really requires a shared vision for space weather, and committed enterprise-wide leadership is needed to really execute on the NOAA space weather missions. As it becomes clearly critical that space weather events have a huge impact on our technological system, and as the society becomes more reliant on technological systems that are dependent or that are impacted by space weather events, decision makers and end users will require more timely and accurate space weather information so they can plan for and mitigate for harmful space weather events. And the one-NOAA space weather effort is really being developed to make sure that NOAA as a agency is well resourced and is well grounded to embrace this challenge and provide the observations and modeling capabilities that are needed by space weather for addressing the global challenge of space weather. So I think with that, I'll stop, and I'm happy to take any questions.
Thank you, Irfan. We have time for maybe one quick question. Okay, if not, we're going to try and have a little bit of question and answer at the end of the next talk.
So yeah, we're moving on to the next speaker.